Okay, so I'm going to begin by showing you putting together some very basic electrical drawings that we're going to use within the 3D. So I'm going to start up See Electrical. Now, our 3D package can either be purchased as an add-on to See Electrical, or an add-on to See Electrical Expert, or as a standalone product. And as a standalone, you can link to existing See Electrical projects or even to a spreadsheet to get your data to say what components and what connections you have within that 3D project. I'm just going to create a new project in See Electrical. This is See Electrical V8R2. And I'll give it a name, Webinar 2020. I'm going to click on Save, and I'm going to select a template, click OK, and just add some schematic pages. So this is just a basic electrical project. We've got a cover sheet in there, and I'm going to add a new sheet to handle the incoming power. We've got a list of circuits, which I'm just going to place down very quickly just to get this going without taking up too much time. I'm going to place an incoming power circuit at 0.00, bottom left-hand corner of the page, and these already have part numbers attached to the components. So these are just circuits, predefined, and I can place these, move these around. I'm going to put on some motor circuits with a power supply, and then click on Cancel. So we've got some information on there with a power supply, some direct online starters. It's going to add a couple of extra pages for a variable speed drive or a variable frequency drive, just so we've got some components to play with in the 3D environment. And I'll put a safety relay. And drop that on there. Now with this project, I'm defining different wire types on here. I'm actually going to link that one back to a contactor on the first page, just to show that information. So that's linked back to that previous page. Just going to add a bit of PLC information on there. PLC main. And I'm going to click on Cancel, and then I'll add some incoming connections on there as well. PLC inputs. Okay, and we've got some links back to the main PLC card that's on that page. So we've got a bit of circuitry in there. I'm just going to check. I'm going to create one more page in this project, and I'm going to work out the thermal calculation for a cabinet. So this is using a function within the software. I'm just going to open up a template before I do that. And this shows just a template view of how the calculation is going to be shown on the drawing, and tell us if we need any air conditioning or heating within the cabinet, just to keep it within thermal parameters. So here I'm going to go and create, do the calculation. Each of the components in here, when we're downloading parts from our web catalog, has a power consumption which is associated with it, and we're just working out the information from that. It's giving us a warning that all parts should have the part number assigned with power consumption for this to be accurate. I've got some missing, I have to admit. I'm just going to select an enclosure. I'm going to select Schneider one, steel framed, 1200 by 600 by 400. On its positioning, I want it to be against a wall on its own. We then go through and we define the temperature, maximum, minimum inside the enclosure, and what it's going to be outside. Power coefficient, 80% maximum power coefficient. And then we look at the power dissipation. We can actually update that if we need to at that point. If we've got a bus bar in there, we've got a rating for that, and then I can go down to results. And here we need some cooling. So we do need a fan in there. So let me just go back. It's going to add a new page. And I'll put Climate Assist fan system. Let's see if I've got something here. I'm just going to drop that in. I just click cancel for that. So on that one, just so that I can recognize it, I'm going to put a location box around that and identify that location as being Climate Assist. And I might actually do the same sort of thing on the front page on these two components here. I'm just going to select those and in the properties put those as being on the door. And the same thing with this one. And I'm going to say that that one is also location door. So some of these push buttons, some of the elements might be in different locations. So I'm just identifying where they are so it's easy to find. So once I've done that, I can now create a 3D panel with those components. So I'm going to go into a new page. Give a description for a 3D layout and then click OK. Just going to use standard template here. This is going to use net routing so that the software is going to work out the optimum routing between the components. If I use wire routing, it's another option with this 3D panel software where the from to information is predefined. And it doesn't matter where you place the components, you've already defined the order in which you're going to connect everything. So I'm going to start with a panel on the left-hand side, and we've got several different areas of information here. This is a list of components which are in the project. I'm just going to load those from the top level, from the function, click on OK, and it's going to bring in a list of all the parts that I've defined in that project. So we've got lots of terminals, some Climate Assist items, and some door items. And we can use the filter on the top to actually pick out different areas or different parts of that panel. So I can see straight away that I've got an enclosure here, which I specified for the thermal calculation. If I click to select the used button, I can see that panel appearing on my cursor, and I can click and place it. So this is in 3D, so I can use my wheel to rotate the image, to zoom in and zoom out, and holding control, I can pan the image around. This enclosure is made up of several parts. So it's a single item that you purchase, but it's coming with a door and a roof and several different elements. So if I double click on something on the page, I can reposition it where I want it. So if I double click again, within See Electrical 3D panel, we've got a mating snap, which allows us to snap to a particular surface on an existing object. And Schneider have been very good at putting all of these objects together so we can assemble them very easily. I'm going to jump to another section here on the panels for the Explorer, and this allows us to see the structure of the project. So here I can click on loading, and I can see that at the top level I have the complete enclosure chassis. Then I have mounting plate, the back plate, and the front door. And in fact, clicking on one of the objects highlights that element in the Explorer, and I can turn these off or make them locked so I can't select and move those. So I've now turned off the door. Let me just go back into a list of symbols. Now, IGE+XAO provide thousands of different symbols for different manufacturers. So we have a huge catalog of parts that you can download and use. I've only put a few of them on here. Obviously, Schneider is there. And from the Schneider Universal Enclosures, I'm going to add some sides. So I'm going to go down to steel floor, spatial SF, accessories, and I'm going to select side panels. And this is 400 deep by 1200 high. So I'm going to choose this top one. And again, as I move to the right area, it snaps into position, and that's done. Now this comes as a kit of two sides. So here I've got one which is extra. I'm going to just double click on it, move around to the other side, and I can see it just switching around. I'm going to hold down Control and just pan across. So you can see those are now fitted. I'm going to scroll down the list, and I want to put a gland plate in the bottom. I've got a big hole there. So I want a 400 by 600. to entry, and there it is on my cursor, and I can just drop that into position. Again, it's just snaps into position. I don't have to be very accurate with this. So it's all been designed so I can just put this together like a jigsaw or like a Lego model. I'm going to put some plinths on here to raise it off the ground. So I'm going to put 100 by 600 front plinth. And again, it comes as a kit of 2 parts. So it looks a little bit strange where it's coming out to the right, but I can just double click on that and drop it on the back. So I don't have to rotate it or anything. And I can put some side plinths on there. Again, they just snap into position as long as I can find where it should snap to. And I can double click, rotate it, and I should be able to see that snapping on the other side. So it goes together nice and easily. At the moment, this enclosure doesn't have a gear plate. So what I need to do, and in fact, I'm just going to turn off the grid so we can see this a bit more clearly on the bottom left. What I'm going to do in my list of symbols is go to another folder for common elements, mounting plates, and I'm going to choose a steel mounting plate, and I want it to be 1200 by 600. So it's that one there. As I move across, I'm holding it in the bottom left, and I can see that there's a mounting strip on the bottom left. There's a mating plate which has been highlighted. As soon as I click on there, I see there are some snap points. So I can mount this at any of those positions, and it's already been lined up for me, so I can just click and place it, and right click if I don't want to place another. But I could put multiple panels in here. When I double click on that element, I can reposition it. So I can actually say, I don't want it right at the back, I want it off the back a bit because I want to put some cabling or something at the back. So that's now in place. I'll zoom back out. So now we can put some of the electrical components onto that gear plate. In the Explorer, we've got a useful way of being able to just identify and just show one item. So I can right click and say hide all except this and anything that's mounted on it and its children. And there I'm just looking now at the mounting plate. Everything else is still in the model. Here at the top, I can right click and show all, but I'm just interested in the mounting plate, so I'm going to hide everything apart from that. I can switch very quickly on here to a front view, and now I can start thinking about placing all my components on the back plate. So I'll start, in fact, not by placing a component, but by going to the cabinets ribbon where we have some intelligent items we can place on the gear plate. So we could just design our own very simple box for the cabinet or a mounting plate, but I'm going to pick a DIN rail, 35 by 7.5, and I'm just going to place that down on the back plate. Choose the size, so I want it to be 400, and then right click. And I've got another one on my cursor. And in fact, I can see that I'm lining these up using what's called the object snap. So here I can snap to the object, to the DIN rail, or to the back plate. And I can see the sort of the center point of each of these. So very easy to position. If I right click a second time, I finish that command. And notice these are not laid on the actual back plate. So one thing I've forgotten here, in the Explorer, I must say which surface I'm working on. So here I should be working not on the inside, the back, but on the outside. I can right click and set that as the working plane. Just going to make that unselectable so I don't window around that. I'm just going to select those items again. Just double click or right click and choose move on a front view, and I'm just going to position those again. And I should see those are nicely laid out on the back plate now. When I click on the back plate, I can see that because of this structure, the rails are part of the actual mounting plate. So when I click on the mounting plate, the DIN rails are also selected. And that's important because if it's a mounting surface, we want to be able to automatically drill that surface so we can get accurate positioning of all the elements. So each of these devices that we place onto a mounting plate will have drill holes on there, and we can show those drill holes, and you can see those are positioned on the back plate. And just by selecting the back plate, right clicking, and choosing to generate drill holes. We have a variety of different formats for existing CNC machinery, for Steinhauer, for Perforex, and for each of these you'll see a preview of how it's going to look with that mounting surface and the objects that are going to be mounted on there with their drill holes. Okay, and we'll have a look at that again later. So I've now got some DIN rails on there. On the list of components, I could now click on a component. Now, in fact, this one doesn't go onto the mounting. It's a drive, and it's going to go onto the back plate. And again, it's got holes on there, and we've already set up the drill holes, so those should already be appearing on our mounting plate. I'm going to place something actually on a DIN rail just by clicking and dropping it onto the DIN rail. You'll see it snaps into position. So each component, if it gets mounted onto DIN rail, you'll see it will snap nicely into position on there. If I select the mounting rail first, then I click on an item. Now this one's got an additional item, an auxiliary contact block. So I'm going to say no for the moment and just show you how that links. I'm going to click on that component and click on the auxiliary and just show you that I can tap K to mount it either on the side, on the bottom, or on the top. So a lot of these components have various mounting positions where you can add auxiliary items. So here again, if I select the DIN rail, I can select a group of items, not by clicking on used, but on the actual component, choose a group of items and just click on insert. So they quickly get assigned, and I can move these around just by double clicking, position it somewhere else, and within a single rail, I can click on the rail and all items are mounted on it. There's a series of rail tools that allow me to align these left or right, so I can shift them all up and work out how much space I need on there. So quick and easy to position things. I'm going to place in a PLC rack, just drop it onto that DIN rail there. And I'm then going to put on some of those PLCs, just drop them on. And I can see there's a mounting surface there, and I can just drop it onto one of its positions. So again, it's child's play to put this together. Very easy. A few more items. I've got a power supply here. Anything on my cursor, I can rotate by typing the letter on the axis, X, Y, or Z. So if I tap Z, I can rotate this once, twice, 3 times, maybe pointing upwards. And then we've got down to, we've got some terminals on here. I'm going to click on one of those terminals, and it's telling me there are lots of terminals on this strip, X1. Do I want to insert all of them? So if I say yes, it's quite a time saving. It's going to bring in all those terminals. And again, even if I'm just slightly off, they snap onto the DIN rail, and I've placed all of those together. I'm going to do the same thing. There are a couple of different terminal strips in this project, so I'm going to drop those in. And again, I could put separators and end plates on here, but for now, I'm just going to place in the terminals. So we're building up this panel from scratch, as you would in reality. I'm just going to drop that down on there. We've got some additional items here for climb assist devices. So let me see if this item here, I'm just going to put this sensor on the back plate. Could go anywhere, to be honest, but I'm going to put it just there. So that's most of the bits that are going to go on the back plate. One more, I think. Here I've got a safety relay, and I should have a bit of space on there. I'm going to drop it. I need a bit of space on here. I'm going to put 5 millimeters on its left. So I'm going to drop it in there, and you'll see it's got a 5 millimeter gap on the left there. So I've got those components now mounted. And again, if there is anything surface mounted, we can right click on the back plate and we can check where the drill holes are going to go. And you can see each item has an outline and drill holes, if it's surface mounted or if it's DIN rail. So that's already been built up. We could save that as a DXF and use that useful information. When at the beginning I loaded that information from the function, at that point, we also brought in all of the wiring information from See Electrical. So in here, we've got a list of all the wires, but at the moment, because we chose a net method of numbering, all it's doing is showing us a list of targets that they're connecting to. So some of these are connecting to multiple items, but the actual wires haven't been worked out yet. So what we do, we just right click on nets and say route all those nets. It warns us all those components must be visible to be routed. So we say yes, fine. Whoa, hang on a sec. Okay, so yes, it's routed them, but what I forgot, of course, is to put some cable trays on there. So it's gone direct. Sorry about that, hang on. Front view, I'm gonna put on some channels. Now, these are cableways. We've got different sized ones. We've got just square ones, which are not particularly exciting, but we've also got some different graphics. So I've got a slotted one in here. So I'm gonna use that one because it looks a little bit nicer. These are adjustable, so when I place it in, I can stretch it to a different size. But notice that the holes are stretching down, but once I've placed it and right-clicked, they go back to being the right size. So they are parametric on their design. I'm just going to place in some cable trays as I go down. And again, positioning is very easy because it's automatically allowing me to position it in line with the existing ones. I'm going to zoom in a bit there. I'm on quite a big grid. I'm on a 25mm grid. So I'm actually going to change that on the bottom left just to a smaller grid so I've got a bit more chance of lining that up without going on top of something. I want some cable tray up the side. So again, I'm going to use Z to rotate that, and I'm going to just drop that on the bottom and then drag it up. Again, just using those handles and the object snaps. Just going to centralize a couple of these bits. So I'm just going to, any of the items can actually be clicked on, and you can choose a modify command to just drag that in a certain direction if you want to. So I can drag that down just a few grid spaces and just snap it onto there. Now you can see as I move something, it's starting to rewire the objects. So if I right click and say reroute all nets, again, it's going to warn me, and I say yes. So now it should be rerouting all devices, and I can see that it's updating that and showing all that wiring. If I move a component from one place to another, so if I double click on this device up here and move it down onto the DIN rail, not a lot of space, but you can see it's rerouted the wiring from there. So it's very quick and easy to get the routing of the wiring information. Once you've routed wires, you can produce a report. If I go to print report, there's a variety of ones that are included. There's a wire routing one here, which just outputs that information to say what's connected to what. So here it's given me a list of those wire numbers. I should have numbered the project because some of these haven't got wire numbers, but I can see most of these are numbered, and it tells me what the wire is connecting from and to, what cable way it's going through, what wire way, the size, the color, and then the length of the wire in millimeters. So it's an accurate list of how the project should be routed according to how we've laid it out. On any of the wires that we've got listed in there, if we click on a wire, we can see that wire highlighted in the background. But also we can change the route. So we can right click, go into wires, and we can say, I want to change that route path. I don't want the wire to go that way. And you've got a list of alternatives because we've got a square routing here which goes all the way around. And instead of this length, I could have it slightly longer, but taking this route. Okay, so there's a whole variety of different routes which you can take. We can also, on a particular component, when we click on it, check its properties, we can also see that we've got a whole series of connection point information on here to say this is the label and this is a segregation code. So I could say that this is a signal. And then with a piece of cableway, I can also put a segregation code and say only allow signals down here. So we can put segregation on the cables to make sure that they only take a certain route. We've got some components which should be placed on the door. So what I'm going to do now is just turn on the whole model. I'm going to right click, show all. And here I want to now place some components on the actual door. So in there, I'm going to set the outside as being the working plane. In my list of components, I'm going to place in some door items. And again, I've got the object snap here for that particular surface. And if I hover over the center, I can say that I want this to go from the center, and then I'm going to hit tab and say that I want an offset of -100 in the X. So that's to the left. Plus 100 would be to the right. So I can be accurate with the positioning. And again, I can line up with the existing one and hit tab and say this is going to go 100 and 0 in the Y. So positioning these items according to exact offsets is fairly straightforward. And I'm not even doing this front on, I'm doing this from the side. Although obviously it would be easier if I did it from this front view. Again, if I check the drill templates or drill holes or Steinhauer, I can see that any of this information is showing where the cutouts for these items are going to be. I'm going to click on close. So we've got those items on there. I'm just going to put on this one, we've got a fan that's needed. So I'm going to go to the right-hand side here, and you can see that that fan automatically rotates to the surface it's going to go onto. I can tap P to say it's going to go on that surface and then click to place it. So that's now been fitted on that side. And I think I've got a similar kind of vent symbol there, which if I just drag this around, and I should be able to then tap P to put it on that plane and drop it onto that side. If I hide the door at the moment and click on here, we can see that these buttons are on the front plane. And if I right click and reroute all the nets, then I'll see how it includes those push buttons in the wiring. And of course, it doesn't really know how to wire to those, so it just goes directly. And I'm not going to be able to really open that front door. So what I need to do on the door is put some cableways on there and link it to the back plate. So what I'm going to do is I'm going to double click to bring the door off. And I'm just going to drop it to one side. Now we've got cables going everywhere, but what I want to do is put some cableways on the back. So I'm going to go to inside, set that as the working plane, and I'm going to put some slightly smaller, so 25 by 25. I'm going to put some cableways on the back here. Just drag this down so it doesn't need to be too big. And one more, I'm going to type Z just to rotate that, snap it against the existing one, and then join it up to that one there. Now, because that's attached, and if I click on this, I can see that these wireways are part of the door. It means that if I was to just double click on the door, let me just go to a front view here, double click on it, it takes the door and all related items and allows me to move those. I'm going to right click and actually click on move onto the front and drop that on there. Now I need to make a link between the cableways on the back and the cableway on the door. And to do that, I can just do a manual routing by defining a path. So on my cable channel path information, I can just define a path up the side of the panel. So from a particular point on the back here, so I could say, take it from, I'm just going to see if I can snap on an end point or maybe between 2 points. This one and this one. And from a top view, I'm just going to drag the route across to the right I'm going to look from a right view and take that back to the door, or up to the door. And then from there, I'm actually just going to very quickly type S to snap, and I'm going to snap it just to this point here, and then right click. Now, just to check if they are linked, I'm going to click on any piece of cableway and show connected cableways, and I can see that everything is highlighted. Just going to set the transparency on there on the top to 45. So I'm going to right click on the cables or the nets and reroute all the nets. Click on yes. Now I can see that a couple of these have taken a direct route, thinking that that's going to be easier than wiring elsewhere. So I can make a bit of an adjustment here. I'm going to go into the wiring. And this allows me to set, for instance, extra wire lengths I can add to wires, either as a percentage or a fixed extra length to each wire. But also I can set the angle from each connection point and the distance that it looks for a piece of cableway. So here I'm going to go to an angle and just reduce that, make it a bit narrower. I'll put it at 60 degrees and just try and see if I can reroute these without it taking an unusual path. Okay, that's a bit better. We would use plugs on those and connect them, so it's a little bit unusual using wires. But you can see now that the push buttons on the top are routing via this manual route that we added. So when I click on a particular wire here, you can see the routing and where it's going. Okay, so we've got wiring on the door, we've got the elements on the side, and again, each of these we can produce a chart or any kind of output to document that information. If I output that information, we can now send this out to a shop floor model. Now there's an additional package with See Electrical and See Electrical Expert. There's an additional package for the shop floor module, which allows you to just have a read-only view of the project, of the 3D model, and follow the routing and mark off when the routing has been done, and just make sure that the routing is the same as the one that's been specified here. So for continuity and accuracy, it's a great tool. So what I'm going to do, I'm going to click on File, save this model, and save it as panel shop floor. Notice as I'm using this, under File, Save As, we can also save the model in DWG, DXF, STL, IGE+, or STEP format. This is all part of the same product. There's no additional modules required for this. So I'm going to go to See Electrical Panel Shop Floor Drawing. I'm going to call this one Webinar 2020 and click on Save. Just before I leave this, there's a couple of things that I've not shown you about the functionality here. So for each cableway, if we want to check if we've got enough space in there, obviously we can visualize it, but we also have a command here for cable channel information. When we click on that, we can see a side profile of that cableway, and we can see a percentage spare that we've defined on the top. So if I drag this bar across, I can see at this particular point, the orange area at the top is the 20% spare that I want to define and keep. If I had too many cables, then this green box would be right up to the top and would turn red to indicate I've got a problem, that cableway is too small. In this situation, there is no problem, there's plenty of space. But if there was a problem, we could then change it to a larger cableway or move some of the components to somewhere else. So each cableway, if I was to click on that one, it's already selected, go into its properties. I can see at the top, this is the channel area size, the density factor, and then the channel occupancy. If I want to allow for 40% spare, I can say, make it 60% occupancy. And there, it's probably going to be a little bit closer. but still enough space in there. So I've got 40% spare. And I can see this first bit on the left is where I've got the most cables. Okay, so for the panel shop, I'm just going to close down the 3D, minimize See Electrical. The panel shop product is completely separate. So when I double click, it opens as a separate program, and this could be running in your shop floor in the assembly next to the machine, and it's been developed to be used with touchscreen as well. So if I click on the pull down box, click on open, and from my desktop, I'm going to use the webinar model. The environment is the same. It's the same engine that we use for the 3D panel package. So I can use the same mouse functions. I don't have a touch screen, so unfortunately I can't use that. But I can zoom in, zoom out, move around it. I've got two main panels, Explorer and Wires. I also have some extra functions. On the top, I have a function to gray out the model. So everything becomes like a ghost, it's grayed out. And a function for zoom navigation. Now, the first thing with the Explorer is that I can put a verification to say that I've mounted a particular item. So I can say that the chassis has been put together. Maybe that's already pre-assembled. But then perhaps there's a top mounting plate. So I would click on, yep, that's been done. So each item, when it comes to, for instance, the door, I can click on a push button, I can see it highlighted and say, yes, that's been mounted on the door. So each item that you finish is then verified. And this could be sent back to the 3D model as a way of checking to say, yes, somebody said they've put that on there and that should now be finished. And it also means that you can interrupt your work, go home at the end of the day, come back, and you know what items have already been finished. Now, more importantly, in the wiring section, we can produce a list of wires either by their number, by a comment, by their from or to destination, by their size or color. So here for number, if I take off any filter and it's already on there, it's listing all of the wire numbers that were in the project. When I click on one, it highlights it, both components. So here I can see a terminal at the bottom, wired up to the power supply. Clicking on each of the items in the from and to highlights that particular item. It tells me the component, the connection point, the size, the color, the signal name, so how it should be labeled, and also a length. So the important thing here is that we can define the routing and be sure that this is what's been done. Check, it's done. Next one. So this is then going through all the components, and once they've been wired, you can click on the check to confirm that that's been wired. We can also take a particular component. So here, if I click on this drive, on the left, automatically it's filtered for just the wires that are on that drive. So whenever I click on one, I know it's just that component. So I can now wire by component. So once each one has been done, I can put a check in there. I can also do multiple filters on here. So I can say, right, I just want all colored wires. And I'm going to click on the filter and say, I want all black wires. So now this is all black wires. But I can also say, I also want all different sized wires. So here on the filter, I can say, I want all black 2.5 mil. So I've got a spool of this out and now go through all the components that I need to wire with this type of cable. So a variety of ways of approaching the wiring, but really useful way of actually following the 3D model, using a touch screen to be able to analyze it, check it, and make sure that what you've got is correct. Once you've finished, as you close this down, you get the chance of saving that information. In the 3D model, if I go back to See Electrical, so I'm just starting up the 3D, sorry about that. So in the 3D model, I can go into File, Import the shop floor information. So I'm importing the same file that I saved, but this time it's got additional information to say what items have been mounted and completed. In my list of wires at the bottom, and in fact, what I can do is right-click and look at this just as all of the individual wires, not as the nets, the different potentials. So I put it into wire mode, drag this up just a little bit over to the one side. I can see that some of these items here are mounted. And in fact, I could filter by that feature and say, show me everything that's mounted. And it's giving me a list of those and saying, this is the marking at the end that should be on there, the distance at the end, the signal name, and these ones are mounted. Double clicking on one on the left highlights that on the drawing so I can see, yeah, that's been mounted. So it's a good way of being able to follow the work and make sure that it's verified. We've still got a little bit of extra time. What I'm going to show you now is, if I close this down, I'm going to show you just the standalone module, but using a spreadsheet to import the data. So if I close down the 3D package, and in this one, I'm just going to go into the standalone package. So this is without See Electrical. So imagine you've got another third-party package, maybe ePlan or WSCAD or AutoCAD Electrical, and you've done a design for the electrical project and you've created a spreadsheet. Now we need minimal information for this to work. We need a worksheet with a list of components with their part numbers, if possible. And then we could also do with a list of the wires. So the wire number, what they connect from and what they connect to. And if you can put a color code and a size, great, that's even more useful. So from that information, from that spreadsheet, we can go into the 3D panel. We can file to create a new project. I'll call it standalone. I'm going to click on save. I'm just going to use wire routing for this one. So this interface is identical to the one that we've seen with See Electrical or See Electrical Expert, but this is standalone. This is working on its own. Both are 64-bit applications. On this one, as a starting point, I could go into my list of symbols and start just placing components and designing a panel. So I can click and place and draw things. Or I could start perhaps with a gear plate, common accessories. If I place that in, I've got a gear plate on there, and I can say that this is going to be the mounting surface. So I can put on a cabinet, define a DIN rail, place that on there, and set the width. And just repeat that a few times if I want to. At this point, I can also link with an external CAD project. So this is where we get to link to a variety of different format files. It could be an Excel file, it could be an external project, so See Electrical, or an Exchange file, an XML file. So here, if I choose XLSX and choose on my desktop this spreadsheet that I just showed you, I'm going to double click on that, import the information from the function, the top level again. Click OK. And it will check all the information and it will tell me if anything's missing. It looks as though there could be some bits missing in here. And we just have a quick look. We can see the parts are just coming in exactly the same as with the module that's part of See Electrical. So you can see the positioning, the placing, the building of the drawing, and this is now driven, the data is driven by the actual spreadsheet. So that's your starting point in this case. Because we've got that wiring information in there, we can also route all of this exactly the same way as the standard product. Okay, so hopefully that gives you an idea of how that can be put together. With the 3D panel package, we can also import from a variety of different formats. So we do have thousands of different components already created. And the key bit of information here that we need to be able to quickly design our panels is where the connection points are going to be positioned on that 3D model and how it's going to mount, interact with other components. So in this case, how it's going to snap onto a DIN rail. Under File, we have the option here of importing from a variety of formats, the same ones we can save as, so an AutoCAD, STL, IGE+, or STEP. So what I'm going to do is just quickly, with the extra time we have, I'm going to show you how we can create a new symbol from scratch. I'm going to open up Windows Explorer. And I'm just going to see if I can find okay, I've got a model here. I'm just going to drag this step file into the window. And here I can see it's appeared at my origin. This is just a step file. So it's a block with no intelligence. So at the moment, I can see that its DIN rail is actually facing the bottom rather than facing where the mounting plate would be, so facing downwards. So the first thing I'm going to do is just Control X to cut it, Control V so it comes on my cursor, and I'm going to move it over towards here and just hit the X key to rotate it in the X direction. I'm just swiveling it around that X axis. So I've now placed that on the page. Now to make it intelligent, so it's not just a step file or a block of graphics, we've got a series of very simple, very quick and useful commands. So here we've got a command, convert the selected block into a component. Double click, it's going to convert it. I'm going to say yes, go ahead. And it says we're going to convert it as a macro and it's going to have a mechanical item in it. But in fact, this is going to be intelligent. It's going to be a component. It could be a standard component like a circuit breaker or a lamp, or it could be a relay coil or a terminal. So it's a component. So when I select this item now, look at the properties, I can see it's got a product name, it's got a prefix. So this is actually for a power supply. So I could put in there a prefix of PSU. I could put the part number in there. To make it intelligent, I need to be able to connect to that particular device. So here on the symbol, I'm going to put some connection points. I select the symbol. Under assembly, I can add a connection point. And here I can click on bottom, click OK, and that's my connection point. I want it in the center of that circle. So using my end snap, I'm going to select between 2 points, point 1 and point 2. And now I can see I've got a connection point. I'm going to repeat that just 3 times. Midpoint between there and there, and then I'm going to cancel. So I've just added 3 connection points. I could have gone on, of course. When I click on that component, I can now, in its connections, say that that's the live, that's a neutral, and that's an earth terminal. So it's now got 3 connection points which we can connect to. So it's becoming intelligent. The next thing, I can actually make it so it snaps onto the DIN rail. If I switch the DIN rail or the component over, I can see this is where it would snap onto, this attachment at the bottom. So what we need to do is just define this as a block plane. In the list, I can define a new plane by 3 points. The 0 point, so that's the starting, the X direction, and the Y direction. And I'm just going to define that as being rail mounted. There's 2 main ones, rail or mounting, if that's surface mounted, and then there's a variety of additional ones for snapping to auxiliaries. So it's now got rail mounting on there. So I've taken a step file, added connection points, and added mounting on there. If I just double click on that symbol, move over to where the symbol would be positioned, add it should snap onto that DIN rail, and I can see it positioning on there. It's a little bit close down, but I can also now wire to that. I can put a manual wire in there just by going to cabinet, create a wire, and I can position from this connection point up to this one, for instance. Obviously, it's not going to wire it if I've said route only through channels. And I haven't got any channels on here, but this is now wiring and it's now able to snap into the right place. Okay, so it's very quick and easy to bring symbols in. Once you've created a symbol, you then get to add it to a symbol database and you're off and working. Okay, so hopefully that's given you an idea of the functionality of this 3D package. I'm just going to open the mic for everyone and just check on any of the feedback, the comments. So I can see that Paul's been very busy. You've been keeping him busy with lots and lots of questions. Is there anything, any feedback that we can work on and answer or that's needed?
I have a question.
Hi, Sam. Yes, go ahead.
The part you just developed there, the power supply.
Yes.
Does that data normally come from the manufacturer, or you have to add it in? And can you share that? So if you developed it, I developed mine in Australia, that we can all share a common database so we're not reinventing the wheel.
Yeah, absolutely. The symbols get put into, you can create your own symbol database, create a database, and you can drop them into a folder there. And they can either be shared as a single database file, so that creates a file in the background, or you can just go into an area in there. You could create a folder, create it as a symbol. So if I select that symbol, right click and create the symbol, then that symbol can then be shared by exporting it. As I say, we do have a large database of existing manufacturers. If I just show you a quick example on the website, and if you've got the web catalog and your maintenance, you'll find you can access this and download this information. So we've got a whole list of different manufacturers here. Each one, when you click on the folder, you'll see there is a section for downloading, and there is a zip file which you can download, which has got the step files with intelligence already added. So this is important. This is from our content team, where we've taken the manufacturer's step files or IGES or DWGs and made them intelligent. Okay, so we do give you lots of information, but a lot of manufacturers nowadays are creating step files or certainly 3D images of their products, which you can add to the software and make intelligent quite quickly. Does that answer your question, Sam?
Yeah, also when I was at SPS Drives last year, they talk about ECAS. Are you guys aligned with the ECAS, so all the data they're putting into the devices?
Yep.
Yep.
Yes, the ECAT side of things is something that's developing. At the moment, it's not something I'm that familiar with, but yeah, certainly it's the way in which devices have been defined. Yeah.
Okay, that's all my questions.
Okay, thank you. Any other questions at the moment that you want to ask over audio?
Oh, I've got another question.
Sure.
There seems to be a lot of intelligence in that Schneider cabinet. Is that something that Schneider actually had, or you guys had to put a lot of time in to get it to that level?
Well, Schneider purchased majority shares in IGE+XAO about 2 years ago, and they're very keen on making this very quick and easy to use for their customers. So they themselves have put a lot of effort into these components to make sure that the cabinets come together really quickly and easily, that you can create a quick bill of materials from that. So yes, the Schneider data is especially good.
Hello.
Hi.
Yeah, hi.
I can hear you. Go ahead.
Okay. I have a question. Whether I mean, is it possible to work in a cloud-based database?
It's something that's coming. At the moment, the cloud-based database is not really particularly well supported. If you create a project on a cloud shared drive, then of course, once you've saved it, everyone has that drive. And file that you're working on is just a single file. So in the background, when I've created this project, it's a single file webinar 2020, 26 megabytes with 10 pages of schematic and a large panel. So
Okay.
that's probably as close as you'll get at the moment, but it's something which has been developed. So certainly, yeah,
Okay.
watch the
Okay.
space.
And yeah, one more thing.
Sure.
Whatever existing tool we use for designing and drawing preparation, can that be migrated into this new one, this IGX?
Do you mean the electrical side of things, or do you mean the 3D?
Yeah, no. I mean the electrical side. For example, there. I think some in eBase we have something called as blocks. We prepare blocks for the requirement blocks in eBase. Whether they can be used, or do we have to create the fresh library?
You may have to create that. We do have a couple of intelligent migration packages, but they mostly work on AutoCAD DWG and DXF files as the interchange format. But if they are created in that format with blocks, then you can bring that in and very quickly make those into symbols.
Okay, some integrators are already existing. Okay.
Yes.
So, is it possible that we can have some literature on those integrators, particularly what type of formats will be accepted, and I mean how they work, and what is the what formats are accepted, and something on that, so that we can see that whether it is possible for our system to come into that this portfolio.
It's something we can work with you and try and find out more information on, but at the moment it's not something that I can show on this demonstration.
Okay.
Okay. So yeah,
Yeah.
we will get information to you and start and work with you and see if we can provide a solution.
Hello, John. It's
Sure.
Royce here.
Royce, how you doing? Good to hear you.
I'm very well, thank you.
Yes, good, thanks.
I have a quick question. This is all looking very good, to be honest with you. Quick question with regards to interference, mechanical interference. For example, if you had a back panel full of some pretty chunky drives, for example, with quite a good depth on them, and you're fitting something like a fan or a door-mounted cooling unit that's in set, is there any automatic detection of interference clashes, or is it more of a visual thing?
Yeah, you can do. On each component, they automatically have a mounting area around them. So you'll see the option here on the top for a mounting box. So on any particular panel, you can check for collision, and there's no collisions. But if I pretend that this one has a larger mounting area, so here on the properties, if I go to its mounting space, I can say, actually, rather than all the way around, on the left, I want it to have 10 millimeters space. Maybe it's a power supply, it needs heat dissipation. Maybe 10 on the right.
Okay.
Okay, so now if we just check that mounting box, you can see it's overlapping those other symbols. So on any panel, if you were to click on check collisions, you see an error. Everything's highlighted in red if there's a problem.
Right.
So yes, you would see that occurring if you had the door on there and everything was on. So if I double click and place a symbol next to it, you'll see it moves away because it's got that mounting box defined and it wants to kind of preserve that. So you'll see that I can't actually put anything close to it once it's defined.
I can see that being really handy with trying to maintain thermal clearances of airflow on inverter drives and that kind of thing. So I can see that being really useful.
Absolutely, yeah, it's a good feature on there. Essential.
Yeah, thanks, John.
Okay. Thanks, Royce.
Hi, John. Can I ask you a question, please?
Andrew, yes, of course. Go ahead.
Can it export directly to a wire loomer machine, such as a Comax?
Some people put just a Y number at each end, and some people like to put the component source and destination in there. So if we export to XML, just call it wires. And then if I just quickly show you that, this is the file wires. And it's already formatted. It's showing you the name, the length, the machine cut and mark. So it's calling the label P01 and then the from and the to information and the color. So again, this can be customized. So yeah, does that answer your question?
Yep, thank you.
Good, thank you. Any other questions? Yes.
Yes, I have one question.
Okay, swap.
Whether we are doing this control and relay panel of like 33 kV, 132 kV, which having the drawing pages more than 100 or 80 pages, like that control panel we are doing with this software. Already we have any example? Like the equipments are mounted in the plus mount option available in the front door, like IEDs or control switches, indication lamp, etc. And we are using for that in a control and relay function like that.
Yes.
If we have any example.
I don't have any other examples, I'm afraid. So no, obviously you can support much larger models. There's no problem there. And we can also, there is a separate module to handle copper busbar. So whether that's something else that you need to look at, it's something that's available where you can draw the copper on the page. You can create copper busbar links, and
okay,
you can
for this
have a higher voltage.
Okay.
Panels.
And
but
for this 10 pages and 20 pages, it took around more than 10 MB, right? 1025 MB, right?
For this project with this model and with the schematic, yeah, it's about 25 megabytes. So, I mean, it depends on the complexity of the models totally. A lot of manufacturers, when you look at the detail, it's incredible, but it's unnecessary most of the time. But all of that detail is adding to the size. If there is a single component that's shown multiple times, then that model is only shown once in the drawing, so there's no impact on the size. But if you have something very large and detailed, then like a panel with lots of screw threads on it, then you might find the size goes up. It just depends.
Okay. And with the one license, we can do multiple machine we can install, or it is a one machine, one license based?
With See Electrical and with the 3D panel, you can install the software on as many machines as you want, but you can only use one license at a time. But when you close the software, and I think you can see that when I close this one, that it asks you if you want to release the license. So here, when I close it, if I say no, it says here, do you want to remove the license? If I say yes, then the license is now back on the internet. This is internet licensing, and it means it can be used on another machine.
Oh. Okay.
Okay, thank you.
Yeah, hello, John.
Sure, go ahead.
What is the sizing of a machine required for storing all the data that we prepare in this tool?
Sorry,
sizing,
what is this sizing of
what?
Sizing
of the machine, of the server.
Of the power. Do you mean for things like the cable sizing? The server.
No. Sizing the server. Yeah.
Do you mean the computer or?
No. For example, all this data will be taking some memory. So people are constantly working on projects, and all the data will be consuming. So is it a centralized application or it is a distributed application? The software, is it distributed or centralized?
The software is local, but the folders that you're working on can be located on a server. So when you install the software, See Electrical and the 3D panel software, you can specify where the folders for your project work are located. So that's just using a network drive. So the software is
so that's what I'm asking. What is the sizing of a network drive to be chosen to sufficient amount of to store a sufficient amount of data in it? Because let's say there are 10 people working on it. Yeah.
Again, I'm not sure how big the projects are, but if it's say 100-page project and 3D design, you're talking perhaps about 50 to 60 megabytes, maybe more. But often the largest space is going to be taken by your 3D models. So you may need a couple of gigabytes to store different manufacturers' databases. So the symbol libraries that you're using.
Okay.
Okay. But I think by today's
Okay.
standards, I don't think it's excessive.
Okay. One more question. Actually, sorry, I joined a little late.
Yeah, no problem.
One question is the panel that you showed on 3D. This
Yes.
panel design is based on the manufacturer panel, or are there fixed model of the design of the panels, or we have to design that also?
You can design your own, but the 3D environment is not particularly geared towards 3D modeling. So you're not going to get stress analysis. You're not going to get any kind of bending functions to allow you
Okay.
to design your panels. Most manufacturers you'll find do create their own models.
Okay.
So it's usually the case of importing a model. So if I go into here and step, and if I drag one of these step files, you can see this is a step file from a manufacturer. And this is quite a common way of actually being able to bring one in and make it intelligent by using that command that I showed earlier.
Okay. This is from which manufacturer?
I'm not actually sure. This is for a customer. It was an Italian manufacturer. So, but it's very similar in the way that things are constructed. You'll find that they're designed in a very similar kind of way. Okay.
Okay.
Thank you. Well, thank you very much for your attendance. I hope it's been useful. And as I say, we're going to put this up on the web as a recording. And if you need to get in contact, by all means do and ask questions. So thank you very much. I hope you have a good day. Stay safe.
Thanks so much, John.
Thank you very much. Cheers, Stephen. Thank you. Have a good day.